So if you remember from the last section, we graphed lots and lots of lines. Some of the lines went this way, some of them went that way, some of them were really steep and some of them were really shallow. Each one of those lines has a different slope, right? That's what we talk about. And if you think about it, you already know what slope is, right? If this represents the road, right, that you're driving your car on, right? What would we say if we were climbing up a mountain, right? So it was a very steep road. Of course, this is too steep. You can't really drive up a steep mountain like this, but we'll exaggerate it. Let's say we're going straight up a mountain. Would you say that this has a very high slope or a very low slope? You would say there's a high slope. Oh boy, the slope of this road is really high. Nobody talks like that, but that's what you would say if you were going to put it in math words, right? What you would really say is this road is steep, right? Steep means slope. Higher steepness means higher slope. Now, what if you're just, instead of climbing up a mountain with a steep road, what if you're going down just a rolling hills, and so, or going up and over some hills with a much more shallow slope? So you would have an intermediate or kind of medium level of slope right there. And then what if you were going along the Great Plains of the, of the country or something, pretty much flat land? You would say that there's no slope here at all. Right? So what we're going to do in this class is we're going to not only talk about how steep something is, we're going to calculate a number for the slope. The higher the number, the higher the slope. So a very high mountain, might have a slope of 100, right? And a very shallow plain, very gently rolling hills might have a slope of 1/2, which is really low, right? So the different numbers just means how steep that line is. So just to kind of drill it home before we actually calculate it, right? We're going to start off with the most flat thing we can talk about. We're going to talk about something that I know you guys have seen. We're going to talk about a very flat line. In fact, it's so flat, we're going to call it horizontal. What do you think the slope of this guy is going to be? The slope of a horizontal line is going to be 0. So we're going to call it 0 slope. Because if you replace the word slope with steepness, we all know horizontal line is not steep at all. It's 0 steepness. So 0 slope. Now in algebra, we use the letter M to represent slope. Right? I'm sure there's some history behind that. I haven't looked it up, but there's a reason why in the past, long time ago, they used the word M. Well, basically, you don't want to use the word, the letters X or Y to represent slope because we use those letters all the time. So we try to pick some other letter that we don't use much, and we use a letter M. So anytime you see M, it's almost always the slope of the line. In this case, the slope is actually 0 because it's totally flat. There's no slope at all. It doesn't actually go up at all. So we say the slope is 0. Now we have, of course, different increments here. Let's see if I can fit all these guys here. We can have a line that is not quite 0 horizontal slope, but maybe it's very gently increasing, something like this. Now, of course, this line can be anywhere, but we're just drawing it where it is right there. We could say this has a small slope. I'm not going to put numbers to it because I don't really care right now, but maybe the M is 1/2 or something, or 1/3 or something really, really low. Right? And then we can have, of course, lines that are even steeper than that, which might be something like this. Steeper than this one, but it's certainly not super, super steep, so I would call this a medium slope. This slope could be maybe 3 or something like this. Or it could be 1 or 2, something like that, all right? And then, you see what I'm doing? I'm increasing the slope as we go along so you can kind of get a feel for it. Now, what happens when you start to get past that halfway point and you start to get into the area of really starting to climb, right? So we have a steep slope here. So this is a high slope. It doesn't matter where the line crosses. I'm just looking at how steep it is. It's steeper than that one over there. So it's a higher slope. So this could be a slope of maybe 6 or something. Who knows? And then this guy, right? Let's go ahead and pick something crazy. Let's say that it is vertical would be straight up and down. This is not quite vertical. It's almost vertical. Very, very gently. In fact, just to show you, the vertical line is this kind of line like this in red. So this thing is not quite vertical, but it's almost up and down. This is what you would call a really high slope. So maybe this slope is like 30 or 50 or something like that. So what's going to happen when you get to the logical conclusion? Notice we started with a horizontal line. What's going to happen when you get way over here so that the line has gotten so steep that it's not just really, really steep, it's actually straight up and down, vertical line. So I'm going to go ahead and say this is a vertical line. What do you think the slope of this is going to be? Well, we've been saying this is the 0 slope. This is maybe a half. This is maybe a slope of 1 or 2. This is maybe a slope of maybe like 6 or 7. This is maybe the slope of like 20 or 30. And then eventually it gets totally, you see what's happening? The slope is getting bigger and bigger and bigger and bigger. So how do you define something that actually is going straight up and down? It's actually totally up and down. So the slope is got to be really, really big, right? As the slope gets very, very, very close to vertical, the slope is going to get maybe to 35, maybe 50. Maybe the slope will get to 100. Maybe the slope will get to 600. And then right as it gets straight up and down, it's so steep that it has an infinite slope because it's going literally straight. You can't even drive up it because it's so steep, right? So in algebra, what we say is that the slope, you don't really say this in algebra, you mostly use calculus and you say this stuff in calculus, but you can say the slope is infinity. But in reality, what you're going to see more often than not in your algebra books is you will say that the slope is undefined. Why do you say the slope is undefined? Because what does infinity mean? Infinity is not a number. It's not like 100 million. That's not infinity because I can always make a number bigger than 100 million. Infinity is not a billion. Infinity is not a number. It's a concept. Infinity means you keep going on never, never, and you're never going to get to the end. It's not a number. So as long as the line is really close to vertical, the numbers will get larger and larger and larger. Really what happens is as the line gets straight up and down, the slope approaches infinity. But infinity is not a real number. It just keeps getting bigger and bigger and bigger. So when you actually have the line literally straight up and down, it's really kind of undefined because you can't give the slope a real number. It's just a concept. It's infinitely big. But for me, I like to think of it as the concept of the slope being infinity, but in your books, it'll probably just say the slope is undefined, right? Because we start here, the slope is 0, it's really flat, bigger, 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 gigantic, infinity. But like I said in your book, you'll probably see it as undefined. Now, one more thing I want to write down before we start graphing some points and starting to calculate the slope here is I want to tell you one more thing. When we have lines that are slanted like this, like if this is the XY plane, when we have lines that are slanted, from the lower left to the upper right, it doesn't matter how steep it is, but I mean anywhere where it's slanted this direction, we say it's a positive slope. Positive slope. So in other words, an example would be like m is equal to 4. That's a positive number, so it has a positive slope like this. And I'll explain why when we calculate slope, why it becomes positive like that. But when you have a line that goes the other direction, what do you think is going to happen? So because in this case, I've been slanting the line the same way the whole time, but lines can actually slant the other way. What if the line goes like this? So this guy is not even slanted the same way, it's slanted the other way. We say that this guy has a negative slope. And what that might be, an example, just an example, m might be -5, right? So what I'm saying is literally if your line points this way, you're going to get positive slopes. And if your line slants the other way, no matter where it is, but if it's slanted that way, you will have negative slopes. And this negative positive business, it comes about because of the way we actually calculate slope. And so that's what we're going to do next. This was just motivation to show you what slope is and to give you an idea of what to expect. Now we're going to actually calculate it. Now, in order to calculate slope, we need to know two things. We need to know the equation, which is actually really easy, and then we need to know what to put into the equation. You only need two things to calculate slope. You need 2 points on the line. Because when you think about it, if you only had 1 point on the line, you don't really know which way the line is pointed. If you only know 1 point, then it's like a pivot point and the line can be pointed anywhere with any slope. So in order for you to calculate the slope of a line, you have to have 2 points. You have to. There's just no other way to do it because 2 points means you're going to define your line going through those 2 points, and then you can then calculate that slope. So first let me give you the equation for the line of a slope, and then we'll talk about why it's the way it is, and then we'll calculate. So the slope of a line, probably one of the most important equations in all of algebra, is going to be the following. M, which is the slope of the line, it's going to be helpful to remember it as the following. Rise over run. I'll explain what rise and run are in just a second. But in math terms, what it is the following. y2 minus y1 over x2 minus x1. Now the reason that we have 1s and 2s here is because we need 2 points. Right? I just told you we need 2 points. So we have point number 1, that's where the 1s are, and we have point number 2, that's where the 2s come from. So let me draw a little picture and explain where this is coming from, and then we'll actually calculate it a few times. So what we're going to do is draw a little XY diagram here. Right? So this is X, and this is Y. Now, I just told you, you have to have 2 points on a line in order to calculate its slope. So let's pick a line that goes through these, well, probably the easiest way to do it is, let me just draw a quick little line here. Doesn't have to be perfect. I don't really care too much about what the line really looks like, because we're just drawing this just to illustrate things here. So here's a little line. We don't need the line to be that long. It could be like this. Now, I need 2 points on this line. I don't care what 2 points is, because the slope of this line is the same here as it is here, as it is here, as it is way over here, and as it is way, way, way over here. The slope doesn't change. This line has the same slope everywhere. So it doesn't really matter what 2 points I pick. I don't care what 2 points. I can pick these 2 points on the line, or I can pick these 2 points on the line. It doesn't matter. So I'm going to pick any 2 points at random. Here's a point that's randomly chosen. I don't care where it is. Here's another point that's also randomly chosen. I don't care what it is. All right? But this point, if you can think about it, this point has some x value. We're going to call it x1. Actually, I'm not going to write it down there. It has an x value for this point, and then it has a corresponding y value. So this point, if you're going to plot it, it could be like 3, 4 or something, or in this case, it looks more like 4, 2, right? But anyway, we're going to call it x1, y1. Whoops, not x1, y1. The reason we have 1s is because it's point number 1. That helps us keep track of it being different than point number 2. But anyway, it has an x value and it has a y value. We'll call it x1 and y1, whatever they are. In real life, they're going to be numbers. They're going to be like 2, 3 or something. But we're going to call it x1 and y1 for now. Now, this is a totally separate point. So because it's a totally separate point, we're going to say that this guy has some coordinates. What do you think we're going to call it? X sub 2, y sub 2. The reason we have the 2's is because it's point number 2. So again, this guy could be, 5, 7 or something. It's going to be some xy point here and some xy point here. We're going to have numbers. But for now, we're not using numbers. We're just using the variables. It's going to have an x and y coordinate, and this one's going to have an x and y coordinate. This is point number 2. That's why the 2's are there. This is point number 1. This is the 1 there. Now, let's talk for just a minute about what slope really is. We know intuitively what it is because we can draw these pictures. You know this is 0 slope. Why? Because it's flat. There's no steepness to it. So when we say rise over run, which is what I wrote there, rise means how much does the line go up? That's its rise. Compared to, that's the division, compared to how much it goes across. That's the run. So if we want to figure out how steep something is, let's look at this line, for instance. It is not rising too much compared to its run. Its rise is very small compared to its run, which is very, very big, right? So this is why it has a low slope. Rise is small, rise over run, rise divided by run. Rise is very small, run is very, very big. So rise over run is a small number over a big number, so you get a small number for the slope. That's why we say the slope is small. But if you move on down the line here to something with a high slope, what does this look like? It has a really big rise. It's going up really, really fast compared to how far it's moving over, right? So rise over run means that you're taking how high the thing goes and you're comparing it to how far over it goes. So when you compare rise over run here, you get a big rise, a small run. So rise over run, when you divide them, you're going to get a big number, which means you're going to get a big slope. So rise over run is defined the way it is because slope of a line is bigger when its rise is bigger compared to its run. So we calculate the rise, we'll show how in a second, but we calculate the rise, we calculate the run, meaning how far over it moves, and we divide those things. And then the number that we get from that is called the slope. If it's 0, the reason it's 0 is because how much rise does this line really have? It has no rise, 0 rise. There is no rise, 0. So 0 for the rise divided by anything is going to give you 0. Because the slope is 0. So that's why the slope is 0, because rise over run is 0. And then when you get down over here, I said m was really infinity. We get over here to the last one. I don't want to go too far in the weeds here, but the rise is really, really, really big. Rise over run, right? but the run, how far over it goes, is 0. It doesn't go over at all. It's totally up and down. So what happens when you divide by 0? Rise over run. We're saying run is 0. What happens when you divide by 0? Well, in a calculator, it's going to give you undefined because it can't really divide by 0. But dividing by 0 is like separating things. How many times can you separate something when the little size is how many times can you divide into something by 0? Well, you can really do it an infinite number of times. So the slope is, we say it's infinity as a concept, but in reality it's undefined because we can't give a number to it, because dividing by 0 is not really mathematically defined. But in higher math, we say, yeah, it's not really defined, but we call it infinity. That's what we do in higher math. Okay, so the reason why slope is rise over run is because we want to figure out how steep this thing is compared to how far it goes over. So now we have 2 points on the line, and now you can see why it's defined the way it is defined here. Because when I take these 2 points, this distance from here to here, this is what we call the rise. This is how far this point goes up. And that's going to be y2 minus y1, because the y2 is how far up on the graph this point is, because this is its y coordinate. It's how far up it is. This is how far up in the y direction this point is. So by subtracting just the y's, I'm figuring out how far this point rises from here to here. That's why it's called the rise, right? This guy, let me see if I can draw it without getting in the way. From here to basically here, when you kind of connect it down like something like maybe like here, right? This is what we call the run. And it's equal to x2 minus x1, because what you're doing is you're taking the x value of this point and you're subtracting the x value of this point. That gives you the distance. Basically, you want to find this distance, how far it goes up, by subtracting y's, divided by this distance, which is how far it goes over, which is x's. You take the rise, which is the difference in the y values, you take the run, which is the difference in the x values, and you divide them, and it gives you a number. If you get a big number, it means you've risen a lot compared to your run, so therefore it's steep. And if you have a small number for m, it means you didn't rise so much compared to your run. So then you have a low slope, or a small slope. So this is all great, but it often doesn't come together until you do a couple of problems. So let's say you have the points 3, 0, and 0, 9. And we want to go ahead and calculate the slope of this line. But before we do it, let's plot these points and see what it looks like. 3, 0 is 1, 2, 3, 0. That's right here on the axis. And 0, 9 is up here on the y-axis. So before we go farther with this, let me put this down. And I'm going to go ahead and just kind of through these two, as best I can, I'll draw a little line. Now let me ask you a question. Based on everything we know before, do you think this is going to have a high slope or a low slope? Right? Well, it's very steep, so it is going to have a high slope. But remember, we talked about, I haven't actually proved it to you yet, positive slope slants this way, but negative slope slants the other way. This guy actually slants in the negative direction, so we expect it to be a pretty high slope, but negative. So like, I don't know, -6 or something. Let me look at it. What do we get? No, not quite -6, but it's pretty high, all right? So let's figure out if it's the case. How do we calculate? The slope is y2 minus y1 over x2 minus x1. What do? You have, this is point number 2, this is point number 1. So you say y2, which is 9, minus y1, which is 0. You have to subtract the y values. And then you subtract the x values and you go the same direction. This is point number 2, 0, minus point number 1, x, which is 3. You get 9 on the top, you get -3 on the bottom, so the slope that you get is -3. You got a negative slope, check. We suspected that it was going to be negative. And yeah, it's not a huge slope, but it's bigger than 1, which is, you know, fairly steep slope. So it's not like -9,000, because that would be like almost completely vertical, but that's what a -3 slope looks like. All right. Now, one thing I want to point out, absolutely important to make sure. When you're calculating slope, you subtract the y values on top, you subtract the x values on the bottom, but you have to do it the same direction for both. In other words, you go like this, 9 minus 0, and if you go that way, then you must go 0 minus 3. The same direction from here to here, and on the bottom you subtract from here to here. They have to be the same direction. Now, it doesn't matter which point is 2 and which point is 1. You will get the same answer either way. Let's calculate the slope again using the same exact equation, But in this case, we'll go the other way. Let's call this 0.2 and this 0.1. So if that was the case, it'd be 0 minus 9, subtracting the y values. On the bottom, we'd have to go the same way, 3 minus 0. What do you get on the top? Negative 9. What do you get on the bottom? Positive 3. What do you get? Negative 3. You got the same slope both ways. So when you calculate slope, I don't care if you take this point minus this point. But if you do it that way, then you must subtract the y values the same way, and then you go back and you subtract the x values the exact same way. If you decide to go this way, subtract the y values this way, that's fine, but then you must subtract the x values in the same way. So that's all you have to remember. So in this way, I'm going 9 minus 0, 0 minus 3, you get this, or you go the other way, 0 minus 9, 3 minus 0, you get the same exact answer either way. So that's a slope of negative 3. And what this means, I'm trying to pull out as much as I can from all of these examples. You get a slope of negative 3. When you think about it, what is negative 3? It's a fraction. You can write negative 3 as negative 3 over 1, right? So back in the beginning, we said the slope was rise over run, right? Normally, like I drew my line initially like this is a rise going up and a run going to the right. So when you say rise over run, you go up this many units and you go over to your next point. But here my rise was negative. So really if you start here, then you can think of your rise being down instead of up. So it's 1, 2, 3 down and you run to the right over 1. Notice that's on the line. Then from this point you can go down 1, 2, 3 and then over to the right. There's still on the line. Then you can go rise downward 1, 2, 3, and over to the right 1. That's still on the line. So at any point on the line, if you use your slope and go rise over run, you kind of stair step your way and you will always still be on the line. That's the point of rise over run on the line. All right? So let's go ahead and calculate a couple more, and we're going to drill that home, I think, a little bit better with examples than just by talking about it over and over. All right? So then we will have, for our next problem, 3, 1, and 5, 5. All right, so let's calculate, well, let's first plot it actually. We're gonna go here, x, y, 3, 1. 1, 2, 3, 1. This is gonna be the point on the line. And 5, 5 means 5 up here and 5 over here, which means we're right here. So those are the points, that's the point on the line. So let me go ahead and graph an intersection of those guys. All right, so there's that one, and there's that one. So that's what our line looks like. Notice that it's slanted in the positive direction, so we expect a positive slope, and it looks to be similar steepness to the other one, so it's probably going to be pretty similar to the other slope, but it's going to be positive instead of negative. Let's see what we actually get. What we say is the slope is equal to y2 minus y1 over x2 minus x1. And I don't care which way you go. I just have to subtract the y values, 5 minus 1. And then I got to go the same way, 5 minus 3 for the x values. 5 minus 1 is just simple subtraction. 5 minus 3, simple subtraction. I get a positive 2. So the slope is equal to 2. And notice that the original pink line was negative 3. I told you it would be about around the same slope because it looks to be about the same steepness, but this one will be positive instead of negative. Now you can extract even more learning out of this by realizing the slope of 2 is really just 2 over 1. It's written as a fraction. So if you think about rise over run, you got to split it into a fraction. How much do you go up compared to how far do you go over? So here we're saying for every 2 units we go up for rise, we go over to the 1 to the right. Let's see if that's true. Pick any point you want on the line. Pick the purple point. Up 2 units over 1. I'm still on the line. Up 2 units over 1, I'm still on the line. Up 2 units over 1, I'm still on the line. Up 2 units over 1, I'm still on the line. That's what rise over run is. It's telling you how far in units, how far up you're going compared to how far over you're going. So from any point you start at, you can always walk along the line using your slope. So we get a positive slope here, which is exactly what we anticipated. All right, and we only have one more problem. And this problem to calculate the slope is going to be 4, negative 1, and negative 2, 3. I want to calculate the slope for this guy. Same thing. The slope is y2 minus y1 over x2 minus x1. I don't care which way you go. Usually I go from here to here. Let's do it backwards just to show we can. Negative 1 minus 3. Y values get subtracted on the top. X values, 4 minus, whoops, we have a negative 2. What do we do there? 4 minus, then you write that -2 in parentheses to make sure you don't mess it up. So when you have 4 minus a -2, you write it like this to make sure you don't screw that up. All right, then what do you have on the top? -1 minus 3 is -4. On the bottom, you're going to have 4. This becomes a +2, which becomes 6. Right? Now you can simplify this by dividing by 2, so you have -2/3. So the slope that you calculated was -2/3. So first of all, notice that it's a negative slope, which means you know the line's going to be slanted in the backwards way, just because it's negative. And secondly, it's smaller than 1. I mean, forget about the sign. It's smaller than 1. So whereas these slopes were like 2 and 3, they were pretty steep, this line should be much, much shallower because it's even less than 1. So let's go ahead and plot it and see what it looks like. What we'll have, let me pick another color, I guess. For the first point was 4, -1. That means go 1, 2, 3, 4, -1. That means I have a point right here. And then -2, 3 means I go left -2, positive 1, 2, 3 here. I'm right there. Let me just double check myself. Yeah, that's about right. And then I'm going to go ahead and connect those 2 dots. All right. So what I have is a line that goes through those 2 spots. It's kind of light. I hope you can see that, but that's basically the line that goes through there. So let's double check our work and make sure that we're right. First of all, we claim that we got a negative slope. And the answer is that makes sense. We do have a negative slope because the line is slanted in the negative way. We said negative slopes go this way, positive slopes go that way. Then we realized that the actual magnitude of the slope was smaller than the other examples, so this line should be shallower than the other examples, and they are. It's actually less than 1, so the slope, this is what a slope slightly less than 1 would look like, pointed in the negative way. And then we can just double check it again by saying, normally when we rise over run like this, we go rise is normally up to, because positive rise is up, and then positive run is over. But when you have a negative slope, what you're really saying, it's rise over run. You can say the rise is equal to -2, the run is equal to 3, right? So what you could do is you could say, let me start from here. I'm going to rise. What is a negative rise? And a positive rise would be up. A negative rise would be down. So you rise down 2 over 1, 2, 3. That's exactly on the line. Then you rise down 2, and then over 1, 2, 3. That's on the line. Then you rise down 2, then 1, 2, 3. That's still on the line. You see, you start at any point, you rise. If it's a negative slope, just rise downward. Instead of rising upward, you're rising downward. It's kind of that's what negative rise means, right? Now, alternatively, I will tell you this because some teachers will teach you differently. The slope is -2/3. You could do it this way, but you could also say that I'm going to go ahead and rise +2, but because the slope is negative, I'm now going to run -3. You see what I mean? In fractions, it doesn't matter if the negative sign's in the numerator or the negative sign's in the denominator, it's still -2/3. So if you want to treat a negative slope as rising down and then running to the right, that's what I do. But some people do it this way. They rise up like normal, and then they run which way? Normally a positive runs that way, they run the other way. So normally rise is up, run is to the right, but with a -2/3 slope, you could do something like this. You could start here and say, well, I'm going to rise up to 1, 2, and instead of running to the right, I'm going to run to the left, -3, -1, -2, -3, here I am. Up to -1, 2, 3, here I am. Up to -1, 2, 3, here I am. Up to -1, 2, 3, here I am. So when you have a negative slope, I'm just doing a couple things here. I want you to see what different slopes look like. That's the main thing. But also, slope allows you to start at any point on your line and stair step along the line to all the other points on the line. That's what the point of the slope is. If you have a positive slope, it's positive rise, positive run. Up is positive, over to the right is positive, just like up is positive y and to the right is positive x. But if you have a negative slope, you have a choice. I can rise down and then run to the right, or I can rise up and run to the left. And I don't care which one you do. I do it this top way, but you can do it however you like. That's why I showed you both. So make sure you understand this lesson. I want you to get some graph paper out. I want you to calculate these slopes. I want you to plot the points. I want you to make sure that you're getting exactly what I'm getting, because it's really important. Because later down the line, we're going to be writing equations of lines. And in order to do that, you have to be able to calculate the slope of the line first. That's the first step. So let's make sure you get your skills down here. Follow me on to the next lesson. We'll get some more practice right now. Learn anything at mathandscience.com.